Has NASA's Perseverance rover uncovered the ultimate secret? The search for life on Mars takes an intriguing turn. Since its arrival in February 2021, Perseverance has been exploring Mars' Jezero Crater, a potential ancient lakebed. This region is a prime candidate for signs of past life, and recent findings have sparked excitement. On September 10th, researchers revealed a study detailing Perseverance's discovery of intriguing minerals on the western edge of Jezero Crater, specifically in the clay-rich rocks of Neretva Vallis. These minerals, commonly associated with organic matter on Earth, have raised hopes of finding extraterrestrial life. However, the study authors emphasize the need for further analysis to determine the true origin of these minerals and whether they are indeed biosignatures. The findings suggest that complex reactions, organic or otherwise, once occurred on Mars, adding to the planet's mysterious nature. One particular rock formation, known as the Bright Angel within Neretva Vallis, has caught the attention of researchers. A rock within this formation, named Cheyava Falls, as scientists intrigued due to its peculiar features resembling poppy seeds and leopard spots. These features, especially the millimeter-sized blobs surrounded by black rings containing iron and phosphate, have sparked comparisons to microbial activity on Earth. David Flannery, an astrobiologist on the Perseverance team, noted that such features are often associated with the fossilized record of microbes on our planet. Perseverance was tasked with a closer examination of Cheyava Falls and other Bright Angel specimens. On July 21, 2024, the rover drilled into Cheyava Falls, collecting a sample named Sapphire Canyon, the 25th sample in its mission. The new study provides a detailed analysis of the Bright Angel formation, suggesting it could be a solid lead in the search for life beyond Earth. The researchers identified tiny nodules and specks enriched in iron phosphate and iron sulfide, associated with organic carbon and formed under low-temperature conditions after sediment deposition. The key lies in the potential for redox reactions, where electrons are transferred between substances, leading to the formation of these minerals. The study authors write, "This organic carbon appears to have participated in post-depositional redox reactions that produce the observed iron phosphate and iron sulfide minerals." Janice Bishop of the SETI Institute and Mario Parente of the University of Massachusetts Amherst, in their News and Views article, state, "The exciting discovery of reduced iron phosphates and sulfides associated with organic compounds in the clay-rich mudstones of Jezero Crater suggests that the organic material might have been involved in the unusual redox reactions." They further explain that on Earth, microorganisms often interact with minerals, converting sulfates to sulfides in cold, oxygen-free Antarctic lakes. While there's no evidence of microbes on Mars today, ancient Mars might have hosted similar processes. Other findings from the team's paper support the idea of a possible biosignature in Mars' Bright Angel formation. For instance, the green-toned specks in muddy clay may contain the mineral vivianite, which could provide insights into specific redox reactions on Mars. However, there's a significant challenge. Confirming the presence of Mars life in Perseverance's sample tubes requires their return to Earth. NASA's Mars Sample Return Program, facing budget constraints and priority shifts since the Trump administration, remains in limbo. Scientists emphasize the limitations of analyzing tiny rock samples from such a vast distance. As the study authors write, the return of samples from Mars for study on Earth, including the Sapphire Canyon sample collected from the Bright Angel formation, would provide the best opportunity to understand the processes that gave rise to the unique features described here. The News and Views authors add, laboratory analyses of samples returned from Mars could also cast light on the potential for prebiotic and even biological chemistry to occur on worlds beyond Earth. The search for life on Mars continues, with Perseverance's findings offering a tantalizing glimpse into the planet's past. The mystery deepens, and the quest to bring these samples back to Earth for further study remains a critical next step.